Hello. Did you know about 244,000 metric tons of gold has been discovered to date, with 57,000 metric tons currently as underground reserves? All the gold that has ever been mined would cover a football pitch to the depth of just 1 meter. Now, gold mine exploration is challenging and complex. Gold mining is one of the most destructive industries in the world. This brings us back to over centuries ago when gold mining began for commercial purposes. Most consumers don't know where the gold in their products come from or how it is mined. It is said that by producing gold for one wedding ring alone generates 20 tons of waste. Ever since, the use of cyanide in mining is, however, controversial, as spills have the potential to inundate an ecosystem with toxic levels of cyanide. Now, cyanidation in gold extraction has detrimental impacts on the ecosystem and the population in surrounding areas. A great number of environmental groups worldwide have been pursuing a prohibition on its use. Thiosulfate leaching, however, is a promising alternative to cyanidation and has recently attracted increasing attention as an alternative to cyanide. Now, however, there is one major problem remaining, and that is a high consumption of thiosulfate during gold leaching. Now, therefore, while thiosulfate leaching presents an alternative green way of gold extraction from refractory gold concentrates, further research needs to be done to study the effects of ammonia and copper as catalysts to improve the recoveries of gold by thiosulfate leaching. Studies to determine the high uptake rate of thiosulfate solution will be another area of focus, as reagent consumption is one major factor affecting the feasibility of the process to the actual operation. Now, the aim of this research is to evaluate the use of thiosulfate leaching process of gold ores to protect human, aquatic life as well as an alternative to replace cyanide. Now, cyanide in the mining industry and to reduce the cost on high consumption of thiosulfate. Now, the objectives of this research would be definitely the first one, to determine the consumption of thiosulfate concentration in leaching of gold ores, and to study the impacts, which is to compare the effectiveness of thiosulfate leaching against cyanide. And finally, to assess the productivity, to optimize leaching kinetics by studying the effects of copper ions and ammonia in the gold by thiosulfate. Now, the experimental design will be divided to two segments, which is the leaching process and the optimization of leaching kinetics of copper ions and ammonia, based on the objectives of the principles are outlined below. To determine the consumption of thiosulfate concentration in leaching of gold ores. Now, this objective involves studying how varying concentrations of thiosulfate impacts the efficiency of gold ore leaching. Therefore, the experiments will be conducted with different thiosulfate concentrations and measure the resulting gold leaching rates. Now, the second methodology would be to compare the effectiveness of thiosulfate leaching against cyanide. Now, the objective is to assess how effective thiosulfate is against a traditional cyanide method in terms of efficiency and environmental impact. This would call for conducting side-by-side experiments with both leaching agents that will provide valuable data for comparison. And finally, is to optimize leaching kinetics by studying the effects of copper ions and ammonia in the leaching of gold by thiosulfate. This final objective revolves around investigating the influence of copper ions and ammonia on the leaching kinetics of gold using thiosulfate. Experiments would be designed to systematically vary copper ions and ammonia concentrations to observe its effects on the gold leaching kinetics. Now, the graphical abstract here is something that speaks for itself. You could see the differences in both experiments that will be conducted concurrently, one with cyanide and the other with the thiosulfate solution, and with the addition of catalyst to the thiosulfate, and the equations for the chemical reactions are also stated as seen on the slides. The risk assessments and managing along with the strategies to minimize the risk will be a crucial study for a successful completion of this research. Operational risk refers to the potential for losses arising from various operational failures, including inadequate processes, systems, people, or external events. It's a subset of risk that we would face in a day-to-day operations and can arise from a wide range of sources such as human error, technology failures, and even regulatory compliances issues. While chemical risk here refers to the potential hazards and dangers associated with the use, handling, storage, and disposal of chemicals. This can encompass a wide range from dealing with the toxicity of cyanide to improper handling of chemicals. So managing chemical risk involves identifying and assessing the potential hazards, implementing safety measures, and establishing protocols to minimize the likelihood of accidents or adverse effects. This includes proper labeling, storage, and transportation of chemicals, as well as providing appropriate personal protective equipment, which is PPE, in handling these substances. So when we talk about risk management from an operational risk perspective, we are looking at equipment failures, sourcing of the gold ores, the supply chain that should not be disrupted, equipment availability by putting students on a rotational basis to use equipment, and also the financial and budgets that are involved. While chemical will be linked to its toxicity of cyanide and the improper handling of chemicals. Now, while the risk managements have been outlined, we need to have strategies to minimize these risks. So we should have preventive maintenance plans in place for equipment, critical spare parts ordered in advance, pre-orders and bulk orders of chemicals that could be shared amongst various master students, rotational work at each lab, engineering controls in place to minimize exposures to chemicals, to have SOPs and SDS on site, and continuous monitorings and trainings that should be provided throughout this research proposal. Now, despite this risk, gold remains a popular and highly valued commodity, and many countries and companies continue to mine and extract it for economic and other purposes. Cyanide may be useful, but the disadvantages of cyanide leaching outweighs its benefits, and when there are other options, why would anyone risk harming the environment and putting people in danger? Now, the latest innovations in mining allow for more responsible mining, and the hope is that these new methods will completely eliminate the use of cyanide in gold mining in the near future. Thank you. I'm Sajita Supaya, here to promote a responsible and sustainable practice, including the use of cleaner technologies and adherence to ethical standards to mitigate the negative impacts associated with gold extractions. Thank you.